you can see there's no correspondence between the ID on one frame and on the next frame. So I mean, literally what's happening here is random IDs are being assigned from frame to frame. If we go to cycle and we go back to frame 0 and run through it again, if we look at this teapot here at the bottom, you can see obviously our IDs follow a rainbow pattern, as I talked about earlier. So we've got red, orange, yellow, green, cyan, blue and purple. Now if we run through this, we get red, orange, yellow, green, cyan, blue, purple. So we get that same relationship. When it gets to purple, it goes back to red, and it repeats, and it goes through that cycle. Gets to purple, repeats. So you know, if you keep watching this teapot here, you can see it's cycling through these range of material IDs and then repeating. That's because we have loop turned on. If we turn loop off, it'll use red, go through the entire range, get to purple, and then it'll stick with purple. So you're stuck with that material ID once it's gone through the entire range. So depending on what you want, you can either use loop, leave loop turned on, or you can turn off loop. Now the sync by options are pretty much similar to the way they work in most other operators. You know, this option, as I said, you know, works in the same way as other operators, and in this case it allows you to define the correspondence between the ID assignment and a particle. So for instance, you can base it on the particle's age, or the absolute frame time, or on the duration of the particles being in the operators, in the actual operator when it enters the event. And this can be useful to randomize the assignment of the material IDs when you're using a particle age mode on particles that are varying ages. And it's very similar to the way it works in other operators. So you just have to choose what option you want. So an example is if we use absolute time and we run through it, you can see all the particles are effectively synchronized, and that's because it's using absolute time. So on frame 0 we've got ID1, ID2, ID3, ID4, ID5, 6, 7, back to 1, 2, 3, 4, 5, 6, 7, back to 1, and it goes on like that. It'll repeat. If we're syncing using particle age, the particles have got different ages because they're born on different frames, and you can see it's synchronizing up that ID to the age of the particle. So there we go. But you can see that each particle is actually cycling through the full cycle of material IDs. If we choose event duration, similar thing. You're going to get almost exactly the same result here, because basically the particles are all birthed at a different time, but they all enter the event at the same time because they're all entering the event on after they've reached an age of 8. So there's not going to really be that much of a variation when you use this option here. And the last option that we have, if you go back here, you can see you've got a random offset. And this is a random offset to the sync by option, so it can be useful when you want to have a little bit more randomness in the assignment of the material IDs. You can turn this on, set up this value, and that will actually offset the ID value by whatever value you put in here. So you've got quite a bit of leeway with that particular option there. So as you can see, the material dynamic operator gives you quite a lot of control over how you actually synchronize up the animation of your bitmaps, or the animation of a particle age map, or how you actually cycle the material IDs in a particular multi-sub-object material. So you can see you've got quite a bit of flexibility there, and you can obviously choose whatever options that suit your particular need. Okay, so that being said, let's move on to the next operator, which is the material frequency operator.